Okay, hi everyone. So we are now comes to the second techniques of integration, which is integration by parts. So we have discussed integration by substitution on the previous video. Okay, alright. So today we will cover this integration by parts. Will have two parts. Okay, two parts of it. Alright. So at the end of this topic, okay, you should be able to evaluate integrals by using integration by parts. Okay, so this method is actually you have um, uh, seen or you have learned this during your SPM. Okay, alright. So we have four techniques. Okay, and for this topic, we focus on integration by parts. So what is integration by parts? So integration by parts is another important method to evaluate integrals, especially when the integrands involve products of algebraic and transcendental functions, such as we have x ln x dx, okay, x exponent x, and also exponent x cos x. So if you look at here, okay, you have two different functions, right? X is polynomial, okay, polynomial function, and ln is ln. So we have two products. So normally if you have two products, so we will use integration by parts. Okay, so integration by parts is derived from the formula for the differentiation of products. So actually it comes from product rule, okay, in differentiation. Okay, where this is the formula uv is equal to integration of u dv dx plus integration of v du dx. Okay, but I'm not going to use this formula. Okay, but I will use this formula. Okay, still remember this formula during your SPM? Okay, so we have the formula which is integrate u dv, okay, is equal to uv minus integration of v du. Means that you need to define what is u, what is dv from the question, and from that you need to find the du, okay, and also v. Alright. As I said just now, so you need to select u and differentiate it with respect to x in order to obtain du, and then you're going to select dv and integrate it with respect to x in order to obtain v. Okay, so we have just now u, okay, and this one you need to have du, which means that from u differentiate to get du, and dv, okay, dv, okay, you need to integrate to have the v only. Alright. Okay, so how to choose u and dv? So I give a suggestion, okay, for the choice. Okay, let a and b be real numbers and n a positive integer. Okay, the following are general forms of integrals solvable using the suitable choice. Okay, for example, we have the first one is x to the power of n ln x as a function, and you need to integrate that function. So you can select u as ln x and dv as x to the power of n. Okay, this is the choice of u and dv. Okay, remember you have the formula just now. We have u dv equal to uv minus integration of v du. So this is actually from, okay, this part is actually from the question. So that's why you need to choose the proper u and also dv. Okay, so next, if you have types of exponent ax sine bx, or is a combination of exponential and trigo, so you can choose u as the trigonometric, okay, and then the dv as the exponential, okay, or you can choose u as the exponential function and dv as the trigonometric function. Right. Okay, number 3. Okay, if you have in terms of x to the power of n exponent, okay, polynomial and exponential. Okay, this is polynomial. So polynomial. So if you have polynomials with multiply with the exponential function or trigonometric function, so you can select u as the polynomial, the x to the power of n, and dv as the exponential or the trigonometric functions. Okay. Actually I have one maybe rules or you can use, okay, where I have the word low pad. Okay, low pad. Okay, normally I will use low pad to choose u. Alright. Okay, LO is for, okay, this is for ln or log function. Okay, P is the polynomial. Okay, E is the exponential function, and T, what do you think? Okay, so T is the another function is trigonometric function. Okay, so we have ln, polynomial, exponential, and trigonometric. Alright, so if you have, for example, polynomial and multiply with exponential. Okay, so we will choose the first function here, the polynomial. Okay, you can have the order here. Okay, the polynomial I will choose as u. Okay, and exponential will be dv. Okay, that's the rule I normally used. Okay, so you can use log-pad. So which function comes first, then you set that function as u. Okay, right? Okay, let's look at this example. Okay, evaluate the following integrals. So we have a function x ln x dx. Okay, here we want to integrate it. Right, if you use log-pad just now, so we have log-pad. Okay, and this function we have x is polynomial and ln is ln or log. Okay, so by using the log-pad rule, so we can see that ln comes first. Okay, so we will choose u as ln x. Okay, and dv will becomes the others. Okay, since we have choose ln x here, as u. Okay, so the rest, which is x dx, will becomes the dv. Okay, so we have u and dv. So from u we can find du. Okay, where first we have du dx. Okay, just right here. So if you have u equal to ln x, so du dx, differentiate ln x. So this one you need to refresh your differentiation skills. Okay, so will becomes 1 over x. Okay, so we need to find du, which is you rearrange the function, so this will becomes 1 over x dx. Okay, why actually we want to find du? Okay, why we need to find du is because, okay, just now we have the formula of v du is equal to uv minus integration of v du. So that's why you need to find du here. Okay, alright, so next is v. Okay, so So v. From dv here, we have dv equal to x dx. So if I integrate both sides, okay, I have dv equal to integrate x dx. So integrate dv, okay, integrate 1 with respect to v, you will get what? V. Okay, and integrate x with respect to x, you will get x squared over 2 plus c. Okay. So now by using the formula, okay, we can substitute, because just now we have u equal to ln x, okay, and our v is equal to x squared over 2. Okay, plus c is actually optional because c is constant. So after you substitute all the formula, then you can put c at the back. Okay, so we have u times v minus integration of v du. Okay, so just now we have du dx is equal to 1 over x, so that's why we will have du equal to 1 over x dx, this one. Okay, alright, so simplify that. Okay, so you will have this formula. Okay, this formula, so you'll have x squared over 2 ln x plus, so this is the solution, so x squared over 2 ln x plus c ln x minus x squared minus 4 minus c ln x plus c. So if you look at here, this is c ln x, this also a c ln x, but one is positive and another one is negative, so we'll get 0. Okay, so it's just only have x squared over 2 ln x minus x squared plus 4 plus c. So that's why I said just now, the answer for v, okay, you can exclude the plus c there. Okay, but don't forget to put plus c at the back after you solve the integration. Okay, alright, so this is just the integration of integration by parts. So more examples will be in the second part of videos. Okay, alright, thank you.